Hi. In task 40, we looked at function machines and we built up to the point where we could use those function machines to solve equations, one and two step equations, equations like the six equations that we have presented here to solve. Now, some of y'all might not have seen task 40. Depends on what class you're in and the pathway you're following. And then some of y'all, well, you might have already known another method to use for solving equations. What I want to do now is you got six questions here. I'd like you to solve these equations. In other words, to find, reorganize the equation however you want using function machines or any other method. And I've given a hint of one other method. Whatever you do to one side of an equation, you do to the other side. And the whole idea, as indicated here, when you're solving an equation, is to work out the value of the unknown. So what should happen is the unknown, in this case x, is on one side all by itself, and the value of x will be on the other side. So for example, should end up with something like where's my draw tool? X equals 6, or x equals 15, or 13 equals x. I'm not saying that's the answer to any of these questions, but that's what your final result should be. What's the value of the unknown? The unknown on one side by itself, and the numeric value on the other side, right hand side or left hand side for the numeric value. So pause, and will you be so kind to solve these six questions your way? Off you go. Right. Okay, so you've done your six, and let's start. We're going to go through these one by one, looking at this idea of whatever you do on one side of the equation, you must do the same on the other. And the fancy term for that you might be familiar with is the balancing method. So balancing equations, okay? And one of the reasons we're introducing this new idea is that, well, the function machines are great. I love function machines, and they're very powerful tools. But there are limitations as we advance into more complicated equations to solve. So we need to introduce new methods to deal with more complicated stuff. So balancing is one of those methods. So let's look through this. For the first one, you had x plus 2 is equal to 8. And you should have got x is equal to 6. But we're not interested in answers right now. Hopefully you have the right answer. We're interested in method. With the function machine method, you would have said that x, well, the operation is adding 2, and as a result of adding 2, you get 6. So going in reverse, 6, the opposite of adding 2 is taking away 2. And I'm saying 6. The output was not 6. The output was 8. I got the answer in my head, don't I? So we add 2, we get 8. So going backwards, 8, we take away 2, and we get 6. So x is equal to 6. That's the function machine method. With the balancing method, look at what it's saying. It's whatever you do on one side, you do the same on the other side. We want x all by itself. That's a big idea you're thinking. The x, the unknown, has to end up all by itself. In this case, on the left-hand side, and we'll talk about left-hand side of the equal sign is equal to the right-hand side. On the left-hand side, we're adding 2. So to balance out, we take away 2 from both sides. And when we take away 2 from both sides, the 2's cancel out. You're left with x, and 8 take away 2 is 6. So that's where how this method works. You're adding. You could be adding something on both sides, taking away from both sides, dividing both sides, or multiplying both sides. All those are options available to you with this balancing method. So study what's happening here carefully, because I want you to really consider this method. Let's look at another one. What was happening? So for x take away 4, we want x all by itself. Balancing method, the opposite of taking away 4 is adding 4. So you add 4 to both sides, and you'll get x equals 7. With the function machine method, you would have thought, okay, well, x, what's happening is that I am taking away 4 to get 3. So going backwards, I need to add 4 to get 7. So x is equal to 7. It does the same job, different method. The function machine, if you want, you can stick with that up to 1 and 2 steps when the x is on one side, the unknown is on one side as per the learning objective. But you want to get your head around the balancing method, or another method I'll show you, because it's going to help when the questions get more complicated. That's the key thing. Here, Multiplying, 3x equals 12. The opposite of multiplying is dividing. So as presented, you could divide both sides by 3, and you'll get that x equals 4. Divided by 3 is what you would have done with the function machine going backwards. You remember this video, you can pause, you can go over these. I'm just showing you the models here, and then you're going to have an exercise to do. For the fourth one you had to do, it was divide by 2. So both sides were being divided by, we had x divided by 2 is equal to 7. So to get rid of to undo the dividing by 2, you multiply both sides by 2, and that's what's happened here. Function machine, it's the same thing would have happened. X is being divided by 2 to get 7. So to get x, we do 7 multiply by 2, and that will give us 14. I prefer the function machine method, but I know its limitations, and that's why I'm introducing you to balancing. Two-stage process now. So when we had 2x plus 5 equals 11, part E, you could have done, and look what happened here, you could have done the balancing, subtracting 5 from both sides. That will leave you at 2x is equal to 6. And then dividing both sides by 2, which will give you x equals 3. And you can pause, and you can read through and study that. Okay, you can pause and you can go through that. With the function machine method, what would have happened? And you'll see it's the same stages you're going through. It's just how you present, how you're structuring your work. A balancing, you're thinking about what's happening on the left-hand side and the right-hand side, where the function machine, you're just making it one string. So for a function machine, 2x means I started off with x as my input. I multiplied by 2. Then I added 5, and the output was 11. So if I want to find the input, I go backwards, 11. I would take away 5. That would give me 6. So you can see what's happening. Exactly the same stages in the balancing. It's exactly the same thing you're doing in the function machine. But on the balancing, using the balancing technique, you keep seeing what's happening on the left-hand side, on the right-hand side. And that matters a lot in more complex equations. It's something that the function, something the function machine can't replicate later on. And then you can see the multiply by 2 becomes a divide by 2, which will give you 3. So the two stages, exactly the same two stages from balancing, can be replicated using the function machine. And finally, for the last one, this one would have been a bit trickier, but pause. I'm not going to read it through. I think I've gotten the message across where you can use balancing. Pause, study that balancing method, and hopefully it makes sense to you, and that's something you think, hey, yeah, I can use that method. Or it might be that you're thinking, no, I want to stay with a function machine, and that's okay for now. For now, it's okay. But to get, as I said, the next stage, stat 42, when the unknown, when the letter x is on both sides, function machine don't work anymore. So we need to introduce something new as a strategy. Balancing is one of the methods, and I'll show you another one in a moment. So hopefully we're okay with that. We'll looked at this one. This one was more, in terms of the function machine, how would we model this one? Well, I'll start off, you always have to start off with your input, your x on the function machine. And what's the first thing that's happening to x? It's being multiplied by -2. And then, and this one was trickier. And you can see where this was harder to model with the function machine, because you need to recall, well, that 3 is actually +3. When I just have the number in front of that 3, that's adding 3. So your second stage was adding 3. I would reckon that many people will struggle to model this with a function machine, but you can see with the balancing, take away 3 from both sides, then divide by 2. It works. It's the same thing we're going to do here, because look what happens. I multiplied by -2. I added 3, and that gave me the 7. When you're going backwards, you have 7. You're going to divide by 3. What am I doing? Not dividing by 3. Sorry, add 3. We're going to take away 3. 7 take away 3 will give me 4. And then we have to multiply by, no, we have to divide. Sorry, and I want to change the colors. That's what's, it's what's going on in my head, is that this should be take away 3, and this would be divide by -2. And if we, so the same steps here. Take away 3 from both sides, but we've modeled it where we lose this idea of two sides, which, as I said, becomes a problem later on. but it's good for these type of questions. Take away 3 will give me 4, and 4 divided by minus 2 will give me minus 2. Minus times a minus gives a plus. Okay, so you can see function machine functions perfectly for these questions. Balancing, doing the same thing to both sides. Taking away 3 from both sides works brilliantly as well. So you have 2 ideas now. I've deliberately not really focused and drilled on me doing the balancing myself. One reason, because I don't actually like it, but I thought it was important to show because for many people that's what was probably first introduced to them. And seeing it presented here, you might think, oh yeah, I like, that's what I do, I'm comfortable with that, and stick with it. Okay, now I want you to do these, and I really want you to use or try to use the balancing method. Okay, but if you think you're not ready for that and you want to go at function machines, that's fine. Make sure you show you're working. Off you go in these, and then I'll start doing them. I'll do all of them with the balancing method. Well, actually, no. I'll do a couple with the balancing, and then others I'll start showing you something new. Maybe. We'll see. Off you go. I'm thinking about it. All right, lovely. Okay, let's make this happen. Balancing method. You've done these, and I'm going to do them. What should have happened? I would have x take away 6 plus 6. I'm going to add 6 to both sides. That's what I'm doing for C. I'm adding 6 to both sides. Actually, I'll do that to make space. I'm adding 6 to both sides, and that means that I'm going to be left with x on the left-hand side. The 6's cancel out. And then on the right-hand side, I have 2 plus 6, which is equal to 8. So the answer is 8. For F, x is being multiplied by 3, but I want x. I don't want 3 x's. I want x. So I got to divide both sides by 3. So both sides are going to be divided by 3. That's the balancing method. And the 3's cancel out. 3 divided by 3 is 1, so I'm left with 1x, which is what I wanted. And then 24 on the right-hand side, 24 divided by 3 will give you 8. The answer is 8 again. For the third one, it's the same idea. It's a multiplication, so both sides we're going to divide by 6. That will leave me with 1x on the left, and on the right, how many 6's are in 54? 9. And hopefully, maybe it was looking a bit more complicated previously because of having to show all the steps in print, but hopefully you're looking at it and thinking, okay, that balancing is not that bad. It's not too much work, and you want to embrace it, because I want you to embrace this idea. Or you have a third option. I'll show you, as I said, there's another strategy we have that we can use. And the last one, no, it's the L. It's not the last one, but I don't want I want x by itself. I don't want the number less 22, so I'm going to add 22 to both sides. I've got to add 22 to both sides. They cancel out, leaving x all by itself. So I've added, and then now I have, well, x is going to be equal to, and I have minus 4 plus 22. Which is what the function machine would have indicated you needed to do. Minus 4 plus 22. And minus 4 plus 22, number line, minus 4, up 4 will get me to 0. And then I wanted to add 22, not 4. So I got to add 18 more, which will take me to positive 18. So x is equal to 18. And we can check. I wasn't talking about the check before, but hopefully you were doing that. Check. 18, take away 22. If I start at 18, go back 18 gets me to 0. Go back 4 more, take away, it gives me minus 4. So 18 take away 22 is minus 4. The previous one, if we look at F, 3 times some number is 24. 8 threes are 24. It works perfectly fine. And then the last one. Oh, let me make some space here. What's actually happening here? The x is being divided by 2, and then we're adding 4 to it to get 5. So the first thing I will want to do, going backwards, the last thing that was happening was adding 4. So going backwards, I want to get rid of that. I'm going backwards. So I'm going to take away 4 from both sides. So in many ways, the balancing, you're thinking about the function machine method, but you're using this left-hand side, right-hand side strategy on paper. But that thought process of what happens first and second, what has to happen last, that does feature. If I take away 4 from both sides, I'm left with x on 2 on the left, and it's equal to 5 take away 4, which is 1. That's the first stage. And then for the second stage now, well, x is being divided by 2, but I don't want to divide it by 2. I want the x, not half of it. So I got to multiply both sides by 2. That will leave me with x on the left, and on the right hand side 1 times 2, which gives me 2. For O, if I was doing that using the function machine, so the answer is 2, what would happen? I would have x divided by 2 plus 4 is giving me 5. That's plus 4 in there. Going backwards, I got to take away the 4, and I got to multiply by 2. Isn't that what we did? We took away the 4, then we multiply by the 2. You can see the link between the two of them. The 5, take away 4 gives me 1. 1 times 2 gives me 2. Function machine method is very powerful. Perhaps easier to understand in this balancing. But we need to get the balancing because that's the only way we can keep having success and go into more complicated solving equations. Okay, so don't throw away the function machine method. Use it, but embrace a new method that will take you further. Right, let's go. We're going to do some practice on these things. We're going to do some drills. Right, here's a rep of 4. I want you to do these 4. I really want you to use the balancing method. Try the balancing method. And then after, I'm going to show you another method that I want you to consider. And then you choose between this and the balancing. So use your method. Balancing is what I recommend, not the function machine. If you got the function machine, great. But really try to get the balancing. Please try. Last resort function machine. Off you go. Right, I'm going to run through them now. Actually, I'm not going to do these. I'm not going to show. Actually, yeah, the balancing. I wanted to, what am I doing? Balancing. I want to drive home the balancing method. So balancing, I'm going to take away 4 from both sides. That's what's going to happen first. And by taking away 4 from both sides, I'm going to have 2x is equal to 10. And then I'm going to divide both sides by 2. And dividing both sides by 2 means I get x equals 5. And at the end of that, I will check. 5 2s are 10 plus 4, 14. So it works. Yeah. Then the next one, what am I doing? I want to get rid of the minus 4. I'm going to add 4 to both sides. That means I get 30 on the right-hand side, and I'm going to have the 6x on the left. Then I will divide both sides by 6, and that will give me x is equal to 5 again. Ooh, interesting. And I check. 6 5s are 30. 30 take away 4 is 26. The check, so important. The third one, I'm going to take away the 4 from both sides. So I'm getting 21. 3x is left on the left-hand side. 3x is 21. Dividing by 3 on both sides, x is going to be equal to 7. 7 3s are 21. I check. 7 3s 21 and 4 25. Is balancing not cool? Balancing is all right. We can do this balancing method. And then 6x plus 10 is equal to minus 10. And you look at the minus number and you think, oh, come on. It's number line work at the end of it. I'm going to take away 2 from both sides. That means I get minus, let me make it a little bit small. I'm going to have 6x on the left, and I'm going to have minus 12 on the right. I don't want 6x, I want x. That means I now need to divide by 2, and that's not number line division. I'm thinking, I have x on the left-hand side, and I'm thinking, what's half of minus 12? Half of minus 12 is minus 6. It is going to stay as minus 6 because the signs are different. Okay, if it was divided by minus 2, then I would have 6 as my answer. But minus 6 times 2 would give me minus 12, and I can check it. Minus, let's see if this actually works. And I wrote, have I written the right thing? Oh my goodness, I know something. You know what happened there, and you can see the power of checking again. I got lost I got muddled up with my numbers, and as soon as I checked, I said minus 6 times 6 is minus 36, and I'm adding 2, and I'm like, whoa, what's going on here? I'm not getting minus 10. The power of checking. What's happened? What's gone wrong? What have I done wrong? What's that? Yeah, I divided by 2. What am I dividing by 2 by? The answer is 2. That was happening. I was thinking about the answer. It's dividing both sides by 6. Dividing both sides by 6. So the answer is going to be x equals 2. Now I check 6 2. Whoa, what am I saying? The answer is going to be minus 2. What is going on with this teacher? Minus 2. 6 times minus 2 is minus 12. Minus 12 and 2 gives me minus 10. We got there in the end. We got there in the end. Woo hoo hoo. So where are we at? We're at a stage we have function machines that will allow us to solve problems like these. This is another set of 4 that I gave you, and actually I'm thinking, why did I call these A, B, C, D yet again? And I'm gonna change these. That doesn't make any sense. After D is E, and then after E would be F and then G and then H. Yeah, G and then H. Okay, right. So, right, we'll do these 4. You got your function machines as a tool, and I'm trying to steer you away from that if you're still using that. And maybe it's worked on, maybe it's not. I don't know, because I can't see. But it's not that I want you to move away from it. Actually, I think if you just had these kind of questions, just use the function machine. It's potentially easier than balancing, you know. But you need to have a range of methods and then choose what's the best or most comfortable method for you to use to ensure you're most accurate in a particular question. It's not just about learning one way and sticking with it, and having lots of tools to solve maths problems and deciding on the best tool at the moment is actually the really, really important skill for you to learn. So I want you to do these 4, but before you do, actually you're only going to do 2 of them, just the last 2. But before you do them, I want to add you another method. I want to show you my favorite method. Okay, so this is what it looks like. The idea I use when I solve equations is this big idea. Change the side, change the sign. Change the side, change the sign. And when I talk about side, what I'm talking about is left-hand side, which is equal to the right-hand side. And the idea just goes, well, anything you move from, if I move that positive 2, note it's positive 2, and if I move it from the left, it goes to be negative 2 on the right. So change side, change sign. Or I could say inverse operation. And you'll see how it works here. 4x is 22, take away 2, which gives you 20. And then I don't want 4x, I want x. So instead of multiplying by 4, which is what's happening on the left, instead of multiplying by 4, I divide by 4 on the right. Multiply by 4 on the left becomes divide by 4 on the right. And I get 5 as my answer, which I can check. 5 4s are 20 and 2, 22. Same thing here. Change side, change sign. I think that's so easy to remember, you know. So instead of adding, if I move the minus 4 from the left to the right, it becomes plus 4. Do the calculation, you get 33. Then the 11, x is being multiplied by 11. I only want 1x, so I'm going to divide by 11. The 11 goes onto the right-hand side. It becomes divide by 11. And 33 divided by 11 is 3. 11 3s are 33. 33 take away 4 is 29. It works. So that's the idea of change side, change sign. And I'm just throwing it out there. That's the way, that's how my brain works. That's how I do it. I don't do the balancing thing. I don't like the balancing, takes long. I sort of suppose for me, this is faster. But maybe you're a balancing person, and that's great. But this is your second option that allows you to do the more complicated questions. So if you're cool with function machines, but you didn't really like the balancing, I want you to think about this. This is my style. If you do it my way is what I'm going to advise. Okay, try any method you want. If you experiment with this method, see how it goes for the next 2, or stick with your balancing. Last resort, function machines, because we want either balancing or change side, change sign for what we're going to do next. We need it. We need one of those 2 for more complicated pieces of work. So off you go. Do the last 2. Right, so now I'm going to do it with change side, change sign. Okay, you did the power of the pause, and you went on. Okay, so left-hand side, right-hand side. I want x all by itself, so that plus 7 has to go. Plus 7 on the other side is minus 7. 31 is not going anywhere, so it stays as positive 31. So I got on my right-hand side, plus 7 is now minus 7. I got 31 take away 7, which is 24. The 6x is still on the left-hand side. All I moved was the plus 4. It's like a game, just moving things around, and the rule is if you change the side, change the sign. Now, I don't want 6x, I want x. So I'm going to write x, but then, well, that's being multiplied by 6. I want to divide by 6. The 6 has to go over on the right-hand side. The multiply by 6 on the left has to become divide by 6. X is 24 divided by 6. X is equal to 4. And then I check 6 4s are 24 and 7 31. That's the idea. Change side, change sign. So yeah, third way to think about the problems. Plus 44 is going to become minus 44, and I'm thinking, oh man, that's negative numbers. 2 take away 44 is going to be on my left. That's what I did. I moved the plus 44. The 7x stays on the right. Sorry, 2 take away 44 is on my right. Now I've got to work that out. 2 take away 44. We're going all the way down on the number line. It's a number line problem, subtraction. When I take 2, go back 2, you get to 40, and you're still left with 42. So to go down, you're going down 42 from 0 minus 42. So 7x is minus 42. Draw a number line if you're not sure and you don't like what I'm showing you there. I don't want 7x, do I? I want x. So x, I'm going to divide by 7. So minus 42 is going to be divided by 7. The multiply by 7 on the left became divide by 7 on the right. And x is equal to 6. 7 6s are 40. Sorry, minus 6. What was I doing there? Woo, that shouldn't happen. You see, that can happen to anybody. It's a negative number divided by a positive number, so we're going to get minus 6. And we check it. 7 6s, minus 7 times minus 6 is minus 42. Minus 42 plus 44, yeah, that's going to give me 2. So yet another method. I've just thrown it out there, and you remember it's power of video. You could go back, look over this, just study it, and change side, change sign, or it's a short. It's like a hybrid between function machine and balancing. Same logic applies, but presenting and thinking through the problem slightly differently. Yeah, but it's the same logic you're using. Let's finish off task 41. Something slightly different. Do these 4. I want you to use balancing or change side, change sign. If you want to stick with your function machine, stick with it. Note carefully what it said. Give your answer as a fraction of a missed number. By whole numbers. I thought it was important to just touch on this idea. Your answer is not always going to be a whole number. So off you go on this one. Yeah, off you go on this one. Pause, have a go, work through it. I would say leave your answers as a top-heavy fraction. Yeah, you're allowed to do that. It's all good. It's all good. Right. First one, 3x equals 4. X is being multiplied by 3. Multiplied by 3 on the other side is divided by 3. X is 4 on 3. Done. That's it. I don't need to make it. You can go and make it 1 and 1/3. How many 3s are in 4? 1 remainder, a third. 1 out remainder, 1 out of 3. Don't need to do that. Get used to top-heavy fractions. I'll make your life easier in an exam. Yeah, okay? Right, next one. I'm rocking my chair, so I just locked it so I can stop rocking. Bad habit. 2x plus 8 is 13. I want x, so I'm going to go 2x is equal to 13. The opposite of adding 8 is take away 8, so take away 8. 13 take away 8 is 5. So 2x is equal to 5, and you're thinking, I've made a mistake somewhere. That's why I'm doing this, and we made it clear you can get a fraction as an answer. The answer is x is going to be equal to 5 on 2. X is going to be equal to 5 on 2. Okay. Then what we got? 8x plus 2 equals 5. So 8x, change side, change sign. The plus 2 goes on the other side, so it becomes minus 2. 5 take away 2 is 3. So 8x is 3. X is going to be equal to the opposite of multiply by 8 is dividing, so 3 on 8. The multiply by 8 on the left becomes divide by 8 on the right. X is equal to 3/8. That's what's going down there. And then the last one, same thing. Plus 7 on the other side becomes, minus 7 on the other side becomes plus 7 on the right. Left minus 7, right plus 7. 4x is equal to 10 plus 7. 10 plus 7 is 17. So 4x is 17. X is equal to 17 on 4. 17 on 4 is your answer. If you want to make it mixed number, how many 4s are in 17? 4, remainder. 1 out of 4, so 4 1/4. 2 out of this was 2 1/2. I forgot that x is 2 1/2. Don't need to make it mixed number unless a question specifically says so. You don't need to do it. You don't need to do it. You got 3 methods now. I hope you've taken on board the balancing or change side, change sign, because in the next task, those are the methods we have to use. Now here we are, task 42, that big moment where the methods, we have to think about method. So far in task 40, 41, and 41, we've been talking about this idea of using function machines to solve equations, 1 and 2 step equations, using the balancing method. So whatever you do to one side, you do the same thing to the other side. Take away 2 from both sides, divide by 3 on both sides. And then the other idea was change the side, change the sign. So if you have a +2 on the left, you move it to the right, it becomes -2. For example, what I have here, +2 on the left becomes -2 on the right. Balancing, you'll take away 2 from both sides. The function machine doesn't work anymore. And that's where, when we have a situation where the unknown, the value we're trying to find, x, it could be any other letter. So far we've stuck with x, but it's going to be any letter. It could be A, B, C, X, Y, Z. It doesn't matter. If it's on both sides, the left-hand side and the right-hand side, it's either we're going to use balancing or change the side, change the sign. And that's why I was pushing so much in task 41 for you to get an idea of balancing or change the side, change the sign. Let's use balancing for A. And if you want to go for it. Go for it. Pause, have a go for it. Compare what you do against what I do. Or as soon as I started, get your aha moment, stop me and do it and compare answers at the end. But I'm going to use balancing for A, and then I'll use change the side, change the sign for B. Okay, so balancing, and then change side, change sign. And I'll actually, you know what, I'm going to write that in, I'll put it in text, make it look nicer. So, wow, change, whoa, we're all over the place here. Change side, change sign. Okay, and that's my preferred method, but you got choice. If you want to stick with the balancing, either one will get you through, and that's what we want. We want methods that can give us success. Because for a lot of people, this is where they get stuck in algebra. They can't do anything more than the 2-step, and we want to get to the stage where we can do these. So let's do this. Let's do this. Now, the first thing you need to have in your mind is, well, remember, to solve, x has to end up all by itself on one side. So the question you're going to have to ask yourself, first of all, before you start balancing, is where is x going to end up? And because I have more x's on the right, there's 4 x's on the right, 3 x's on the left, I'm thinking x is going to end up on the right. But what I'm going to do to ensure that, and to deal with the whole thing, I'm going to take away x's first. I'm going to take away 3x from both sides. So in other words, the x that's on the left will disappear. So I'm going to take away 3x from both sides. As a result of taking 3x from both sides, all that I'm left with is 2 on the left-hand side. And on the right-hand side, I took away 3x. 4x take away 3x's, leaves me with 1x, then I have take away 3. So x take away 3 is equal to 2. And don't let the idea that the x take away 3 is on the right, don't make that let you feel uncomfortable. Okay, it is what it is, and we got to run with it. Now, I want x. I don't want x take away 3. I want x. So that take away 3 needs to go. And how do you remove a take away 3? By adding 3 to both sides. Because the -3 plus 3, that'll cancel out. So now I'm left with, on the right-hand side, I'm left with x. On the left-hand side, I have 3 plus 2, which is 5. Now that looks a bit funny. It's right, but it looks a bit funny. The convention is that what you'll do is just swap things around at the end so that the x is on the left. So I will rewrite this to say that x is equal to 5. And now I will check, does this actually work? 5 3s are 15, plus, I check my substitution. It's important. 5 3s are 15 and 2 is 17. 4, 5 4s are 20. 20 take away 3 is 17. So I'm getting 17 on the left, 17 on the right. It's correct, sorted. The answer, x equals 5. And that's using the balancing method. I took away x's from both sides. I did it in such a way so that I will only end up with x, 1x on one side. In this case, it was on the right-hand side. And then I continued. I had x, but still had a minus 3. So to get rid of the minus 3, I added 3 to both sides. Let's use the change sign method. Now look, I have 2x on the left, 8x on the right. So still we're in this situation. It won't always happen like this, but in this situation, we have more x's on the right. So with this method, 8x is going to stay where it is. All the x's are going to go on the right, and all the numbers have to go on the left. So that means it's the minus 11 that will have to move, and the 2x will have to move. And that 2x, you need to keep in mind, is positive 2x. So that's the strategy. That's the game plan. I have more x's on the right, so all the x's go on the right, and all the numbers go on the left. That's the game plan. That's the strategy. So minus 11 on the right needs to go on the left, and that means minus 11 will come positive 11. The positive 7 never moved. It's still where it's at, so I'm going to put that in, positive 7. And positive 7 and positive 11, that's going to give me 18. So I got 18 on the left. And then on the right, the positive 2x has to go on the right, so I'll put that. That becomes minus 2x. Positive on the left becomes minus on the right. And 8x take away 2x is going to give me 6x. Now, after making that swap, look at what I did. I got all the x's on one side, in this case the right side, all the numbers on the other side. At the end of that swap, I have 6x is equal to 18. I don't want 6x, I want x. So it means I need to write x. I need to divide by 6. The multiply by 6 on the right becomes divide by 6 on the left. So 18 divided by 6 on the left, x is equal to 3. 18 divided by 6 is 3. And the convention is we want to use the unknown on the left-hand side, so I can just rewrite it as x equals 3. X equals 3, but we can read from left to right, x equals 3. Two methods, they both work. Function machines don't work anymore. Are you going to be a balancing person? Are you going to be a change the side, change the sign? Or are you going to use a hybrid? Some people mix and match. Not even me. I was thinking just now, when I got to 18x take away 6x, I was thinking, divide both sides by 6. I was actually thinking balancing was what I was going to do. But it works. Either method. You stick with what works best for you. I'm just hoping by showing this that at least one of these methods you think, yeah, I can make headway, I can do this. And with that in mind, I'm going to give you an exercise to do. I'll do a couple more within the exercise, but in general, I'll just provide the answers. You have two methods, balancing or changing the side, changing the sign to work with. So here are 8 of these questions to do. First 6 from an exercise, then I've added 2 additional ones. I know constraints on time, and you might not be able to do all 8 in one go, but if you're not able to finish all 8, please try to do the others, and then you really want to do these, and I will have more for you to do in task 43, but have a go at these. I'll provide the answers, and I'll actually look at a couple myself. There's I think F is potentially interesting. I and J, there's something new there as well. So have a go at these. Use the method you prefer, balancing or change side, change sign. Off you go. All right, the answer in terms of answers, these are the answers you should have had. Lots of 3s. Please pause, mark your work. The beauty is that you probably know if your answer is right or not because you could have checked. You notice in a lot of my work I've been checking. Happy that you pause, you mark your work, green pen or a different color pen to make notes, corrections. I want to do these too. Okay, so you've had your chance. You could go back. Remember, it's video. You can pause. I'll work through these too. For f, the difference here was you had to do simplifying before solving because you have 3x plus 5x. It's actually 8x that you have plus 2 on the left-hand side, and then 8x plus 44 on the right. We have a situation now, once we've simplified that, well, we have more x's on the left than on the right. And by the way, if you didn't do this or you didn't get it right, you have your aha moment. It's like, oh, that's what I needed to do. Then finish the job. Then compare against what I did. Take the power, make sure you're doing as much of this work yourself. What I'm going to do, I'm going to keep 8x on the left-hand side. But the x on the right, which is actually positive x, that has to go onto the left, and that becomes minus x. So all my x's are going to be on the left, which means all my numbers have to be on the right. And I just remember mirror vision. This, when I do this, this is you're seeing it on the left. Ooh, technology, cameras. Right. So the x is gone. The plus 44, all the numbers are going on the right. So plus 44 is going to stay there. So I can leave the plus 44. It's the minus 2, sorry, the plus 2 on the left-hand side has to become minus 2 on the right-hand side. So that's the swap I've made using change side, change the sign. X, all the x's on the left, all the numbers on the right. The positive 2 became negative 2. The positive x became negative x. Now I can do 8x take away x, which will give me 7x. And 44 take away 2 will give me 42. And at this stage, as I talked about a mix and match strategy, I will divide both sides by 7. I can divide both sides by 7, giving me that x is equal to 6. So the answer x equals 6, as we were presented previously. And then for J, balancing, I have more x's on the right, so I want to get more x's on the left, sorry. 4x on the left, 2x on the right. Let's do this by balancing. I want to get rid of all the x's on the right-hand side, so I got to take away 2x. And if I take away 2x on the right, I have to take away 2x on the left. No more x's on the right. I'm now left with just minus 8 on the right. On the left, the 4x take away the 2x, well, that's going to leave me with 2x, and I still have minus 2. So 2x take away 2. Let's just draw a line down here. Okay, great. Now, I don't want 2x take away 2. I want x. So the next thing that needs to go is the take away 2 on the left. So to get rid of that, I'm going to add 2 to both sides. I need to add 2 to both sides. That will leave me with 2x on the left-hand side, and on the right-hand side, minus 8 plus 2 will give me minus 6. And finally, we did not want 2x. Remember, it's x. That's the idea of solving an equation. You get the unknown all by itself on one side. So x, I need to divide by 2, both sides being divided by 2. That will give me x is equal to minus 6 divided by minus 2, which is minus 3. So that is your solution, and that is working out the question using the balancing method. For the other one, F, I use the change side, change sign method. Which method is your method? Which method you prefer? Looking forward to finding out more about that. The key thing is you have to embrace, you want to get your mind around at least one of these, so that you can get on to more complex work in algebra. That's all for now. Bye-bye.